Hello, and welcome to Math Lessons with Linda. Today's topic is simplifying radicals that have a higher index than just a square root. Here's our first problem today. The cubed root of 81, x to the 8th, y to the 9th. It's very useful if you're familiar with some of the perfect cubes and some of the perfect fourth roots. We'll talk about a couple of these as we go through today. So the first thing I'm going to look at is my number 81 and figure out if I have any factors of 81 that are a perfect cube. And I do. The cubed root of 27 is a perfect cube. And the other factor for that would give me my 81 is the cubed root of 3. So I've taken 81 and broken it down into a perfect cube, which is 27, and then the leftovers is the cubed root of 3. So let's hang on to that for a minute. Let's take a look at our variables. So a variable is a perfect cube if the exponent that you have is divisible by what your index is, in this case a 3. So 8 is not divisible by 3. So what I have to do is similar to the numbers that I broke down. I'm going to find the largest value for my exponent that's divisible by 3. So 6 is that value for the exponent. That means that I have an x squared left over. Remember that when you're multiplying, you would add the exponents together. So 6 plus 2 is how I'd get my 8 back. So I think what I'm going to do is underline the factors that are the perfect cubes, and everything else is what's going to stay underneath our radical. So the last thing I have is this y to the 9th, and 9 is divisible by 3. So it's already a perfect cube. So I'll just underline that. So now we've done the hardest part of the problem. We're going to go back now and just evaluate these cubed roots. So the cubed root of 27 is 3. That means that 3 times 3 times 3 would give me the 27. The cubed root of x to the 6th, remember the shortcut is to take the exponent, divide it by the index. So 6 divided by 3 is going to give me an x squared. And the y to the 9th, I'm going to divide 9 by 3, that's y to the 3rd. So all of these factors, I've already taken the cubed roots of and used them. So everything that I have left that I didn't underline is what is not a perfect cubed. So I've got a 3 and an x squared factor. So my final answer for this problem is 3x squared y to the 3rd times the cubed root of 3x squared. And that is one example of how you can simplify with a higher index. Let's look at one more. This problem is a fourth root. So the fourth root of 16 m to the 12th into the 5th. I'm going to start with my 16, and it turns out that 16 already is a perfect fourth root. Remember, this is what you're asking yourself. Is there a number that if I multiplied 4 of them together, I would get my value under the radical? In this case, 16 is 2 times 2 times 2 times 2. So I'm going to underline this. That is a perfect fourth root. The next factor is that m to the 12th. So 12 is divisible by my index 4. So it turns out that I don't have to split up my m to the 12th either. That is also a perfect fourth root. When I get to the n to the 5th, I am going to have to split that up because I will have the next smallest number that is divisible by 4 is n to the 4th. That means I have an n to the 1st left over because 4 plus 1 would give me that 5. That is the perfect fourth root. So let's evaluate this. The fourth root of 16 would be 2. The fourth root of m to the 12th, we divide 12 by 4 and get m to the 3rd. And the n to the 4th, 4 divided by 4 gives me into the first. So all of this comes outside of your radical. And this time, all we have left is the 4th root of into the first. So this would be our final problem. And that is how you simplify radicals that have a higher index.